Good day, students. Welcome to our pre-calculus class again. Now we are going to talk about ellipse. What is an ellipse? An ellipse is the locus of all points in the plane, the sum of its distances from two fixed points. The first focus and the second focus is a constant. Now, each of the two fixed points is called the focus of the ellipse. Together, we refer to them as foci. Unlike a parabola, an ellipse is closed, but just like a parabola, an ellipse always devours its foci. The line that passes through the foci is called the principal axis of the ellipse. An ellipse is always symmetric about its principal axis. And the principal axis will always hit the ellipse at exactly 2 points. Each of these 2 points is called the vertex of the ellipse. Together, they're called vertices. Now, unlike the parabola, an ellipse always has 2 foci and 2 vertices. And the midpoint C of the foci, which is also the midpoint of the vertices, is called the center of the ellipse. Note that the parabola has no center. Okay. Now we will proceed to the theorem. Equation of an ellipse with center at the origin in standard form. So there are 2 cases here. Case 1, the foci at F. We have positive and negative C and 0, and the vertices at the V. We have the positive and negative A and 0. So the equation for this is x squared over a squared plus y squared over b squared is equal to 1. In case 2, we have the foci at F, 0, the positive and negative C, and the vertices, 0, and the positive and negative A. And the formula is y squared over a squared plus x squared over b squared is equal to 1. So you have to take note of these 2 formulas so that you will know what equation you're going to use. You have to base case 1 or case 2. Now we will proceed to example 1. Sketch the following ellipse showing its vertices and foci. The given equation is x squared over 25 plus y squared over 16 equals 1. You have to take note that the value of a should be the greatest. So since 25 is greater than 16, we must have a is equal to 5 because the square root of 25 is 5. And b equals 4 because the square root of 16 is 4. And to get the c, we have the square root of a squared minus b squared. So a squared is 25 and the b squared is 16. So square root of 25 minus 16, it is 9. And the square root of 9 is 3. And this ellipse falls under the first case, so that its foci are positive and negative 3 and 0, and its vertices are positive and negative 5. And with the help as well of the minor axis, we can sketch the graph of this ellipse. So this is the graph. So we have the C, just the focus, we have positive and negative 3 and 0. And the A, we have positive 5 and negative 5 and 0. And the B, we have positive and negative 4, 0 and positive and negative. So this is the sketch for that ellipse, that is x squared over 25 plus y squared over 16 equals 1. Okay, next is example 2. Find an equation of the ellipse whose center is at the origin and with foci at positive and negative 5 and 0 and vertices at positive and negative 7 and 0. So we know that the ellipse falls under the first case of the theorem. With C equals 5 and A equals 7 because at the foci, that is the C, and the vertices, that is the A. So how to get the B? We have to get the square root of a squared minus c squared. So we have the a squared is 49 because 7 squared is 49 and the c squared is 25 because 5 squared is 25. So 49 minus 25 is 24. So the value of b is square root of 24. Thus, an equation of the ellipse is, okay, we will substitute these numbers to the given formula. We have x squared over a squared, which is 49, plus y squared over 24 equals 1. Why 24? Because that's the value of the p squared. Okay, next theorem. Equation of an ellipse in standard form. So let A is greater than C is greater than 0 and B is equal to the square root of A squared minus C squared. So an equation of the ellipse, the center is at C, we have H and K, meaning the center is not at the origin, with foci at the first focus is H plus C in the K. The second focus is H minus C in K. And vertices at V, the first vertex, we have H plus A in K. And the second vertex is H minus A in K is X minus H squared over A squared plus Y minus K squared over B squared equals 1. And the next case, we have foci at F, we have H and K plus C, and second focus is H and K minus C. And the vertices, we have at B, H, K plus A. And the second vertex is H, K minus A. Is Y minus K squared over A squared plus X minus H squared over B squared equals 1. So these are the two formulas that you are going to take note in an equation of an ellipse in standard form. Okay, example number 3. Sketch the ellipse showing the center, foci, vertices, and the endpoints of the minor axis. 25 times x minus 2 squared plus 9 times y plus 4 squared equals 900. So, ang atong first nga buhaton is, we have to transform the equation into standard form since that is not in standard form. We have the standard form is x minus h squared plus y minus k squared. Again, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So that's the formula in case number 1. And the given equation is not in standard form. So we need to divide 900 all the terms. So we have 25 divided by 900 is 1 over 36. And 9 divided by 900 is 1 over 100, and 900 over 900 is 1. So that's a standard form of the equation. Okay, the center is then C, 2, and negative 4. Since 100 is greater than 36, we must have A equals 10 and B is equal to 6. Thus, C is equal to the square root of A squared minus B squared. So as we know that A squared is 100 and the B squared is 36 because that's the given. So the square root of 100 is 10, so that's A. Remember that A should be the greatest. And square root of 36 is B, so that's 6. The square root of 36 is 6. So to get the C, we have square root of A squared minus B squared. We have 100 minus 36. that is 64, and the square root of 64 is 8. Now to locate the other required points, identify the principal axis first. Since a squared is equal to 100 is with y, the principal axis must then be x minus 2 equals 0. Thus, the foci and vertices all have the abscissa 2, or the x value 2. So we have the foci at 2. We have negative 4 plus and minus 8. And the vertices at 2, negative 4 plus and minus 10. So meanwhile, the endpoints of the minor axis are at 2 plus and minus 6 and negative 4. And we have the sketch here for the ellipse below. Okay, again, the formula for this. So what case is this? We have case number 2, because the a squared is together with y, because 100 is the greatest denominator there. So that's case 2. The formula is y minus k squared over a squared plus x minus h squared over b squared is equal to 1. And to get the focus, we have the h. Okay, we have the h here. Y, we got 2 and negative 4 as the center. Okay. The center is the h and the k. Here at the numerator, diba, we have x minus 2 squared and y plus 4 squared. So the value of h there is 2, and the value of k is negative 4. Because y plus 4 can be written as y minus negative 4. So our center is 2 and negative 4. And to get the foci, the formula is h equals, h and k plus and minus 6. So our h is 2 and our c is 8. And our k is negative 4 there at the center. So we have 2, negative 4 plus 8 is positive 4. And negative 4 minus 8 is negative 12. So if the center is at 2 and negative 4 here at the graph, our foci also is tungod pod siya sa 2, dayon sa 4 o sa negative 12. Yung atong vertices, 2, tungod pod siya sa 2, and then negative 4 plus 10 is 6. So tungod siya sa 6 o 2. 2 and 6. So this one. And we have negative 4 minus 10 is negative 14. So these are the vertices. And the endpoints of the minor axis, we have 2 plus and minus the b. So 2 plus 6 is 8. So negative 4. So we have our x is 8. Our y is negative 4. And then 2 minus 6 is negative 4. And negative 4. We will draw the ellipse. Okay, example number 4. Find an equation of the ellipse having vertices at negative 3 and negative 4 and 7 and negative 4 and whose minor axis is length 4. Okay. And another is whose center is at 2 and 7 having a focus of 2, 1, 10, and having an endpoint of its minor axis at 4 in setting. Okay, we keep in mind that the essential ingredients to the equation are A, B, the center, and the principal axis. So to determine which variable will join A in the equation, from the vertices, which will just denote by B, the first vertex, and the second vertex, we immediately get the center. So we have our center 2 and negative 4. Why 2 and negative 4? Being just there, midpoint, and A equals 2A is equal to 7 minus negative 10, that is 10. Thus, A is 5. Why 5? Because the half of 10 is 5. So we note that the computation above relied on the fact that the vertices is horizontal. This then claims that the principal axis is horizontal with the equation y equals negative 4. Now the length of the minor axis is 2 times the b. Thus, we have b is equal to 2. Therefore, an equation of the ellipse is, that's the first case, x minus 2 squared over 25. Because the value of a is 5. So 5 squared is 25, and the value of b is 2, and 2 squared is 4. So that's the equation. And in example 2, we immediately get from the given focus and the center. We have C is the absolute value of 7 minus 10, which is the absolute value of negative 3 is also 3. And that the principal axis is the vertical line x is equal to 2. Because the value of x, the center is 2, ang focus with 2. So, ang x is equal to 2. So, from the given endpoint of the minor axis, we get b is equal to 2 minus 4. Because the value of x at the minor axis is also 4. So 2 minus 4 is negative 2, and the absolute value of negative 2 is 2. Finally, we obtain a. We have a squared is equal to b squared plus c squared. So our b squared is 4, and our c squared is 9. Because our b is 2. So 2 squared is 4, and our c is 3. So 3 squared is 9. So 4 plus 9 is 13. Therefore, an equation of the ellipse is second case. So we have x minus 2 squared all over 4 plus y minus 7 squared all over 13 equals 1. Okay, we will go to the historical vision, ellipses, and planetary orbits. An important application of the ellipse is in planetary motion. Precisely, Johannes Kepler discovered that the planets revolve around the sun in paths shaped as ellipses, having one of the foci at the sun itself. Before Kepler uncovered this fact, people believed the planets traveled along circular paths, circles being the most symmetric among all conic sections, symmetry being an ancient criterion for being perfect, and the universe being believed to be utterly perfect in those times due to the Greeks. They also thought the other planets and the sun revolved around the earth. So that's the history of ellipses and planetary orbits. So for our integration of faith and learning, like ellipse, there is a focus or the foci. Please have the focus with your studies because God has prepared a brighter future for you. Trust Him always, and He will lead you in every way. Remember His promise in Proverbs 3:5-6. Trust in the Lord with all thine heart, and lean not unto thine own understanding. In all thy ways acknowledge Him, and He shall direct thy paths. Thank you, and I hope that you learn about ellipse today.